All right, chapter 3 review for the cumulative. Explain transformations on number 1. Well, there's 3 transformations going on, right here, here, and here. So the 2 on the outside means it's going to be narrower, okay, or vertically stretched. Okay. The -4, remember, inside lies. These are also good things to put on your cheat sheet to remind yourself of all the different situations where inside lies, whether it's in the top part of the exponent, if it's in a parentheses, or if it's underneath a radical, inside lies. So you see -4 and you think, oh, left 4, inside lies, it's moving right 4. And the -7, which is outside, is not lying. So when you see negative, you think down, and it is correct. It is down 7. Number 2, we're looking at a graph. So we perform the vertical line test. Anywhere I hit a vertical line, I'm only hitting one spot. So therefore, it is yes. Okay? Because it passes the vertical line test. All right. The box up here, we're looking for repeats. So in the X, now we notice there are repeats in Y, but that's okay. Okay? Think about a calculator. There's more than one way to get -3 on a calculator. That's the output. We could do 2 minus 5. We could do -3 times 1. That's okay. We're looking for repeats here. 2, 4, 6, 8, 10. All one input, so it's yes. And the reason is each input has only one output. Repeats in the Y are okay. It's repeats in the X that we don't want. Here, we have no numbers, okay? It doesn't really matter. The idea is this input has one output. This input has one output. This input has one output. Here's the problem. This input has 2 different outputs. So if I wrote 5 plus 2 into my calculator and I got 7, so I did 5 plus 2 on my calculator, I got 7, but I also got -8. That means my calculator is not functioning. It's broken. So it's no, because one input has 2 outputs. One input has 2 outputs, and that's a big no-no. All right, graph each of the following functions, give at least 5 exact points. Let the calculator do the heavy lifting for you. So in this case, pull up our calculator. If it works, not what I want. There we go. Go to y equals. Clear out whatever's in there. To make life easier, I just use 0.5 for 1/2. Absolute value. Remember, absolute value is under the math key. You go over, nope, wrong way. Over here to number, absolute value. Put in x plus 4. Come outside the absolute value and put -2. Hit graph. Let it do the heavy lifting for you. That's what it should look like. There's no reason to get this wrong. So we go to second graph and get some points to put on here. Okay? And you're just going to look for whole numbers, like -4, -2. Right here. And -1, let's see, -2, -1. Right there. 0, 0. 2, 1. And let's see where it makes the turn. -6, -1. So we have where it makes the turn and going that way. All right. So type is absolute value. The domain, remember, domain is left to right. So it's going from -infinity to +infinity forever. The range is how low and how high. So you can see here that it bottoms out right here at -2. It hits -2, so we use a bracket, and it's going up forever to +infinity. Okay, the next one, you can even do this first. It's a 3, so that's a cubic. And domain on a cubic is always -infinity to +infinity. And all we're going to do is, again, put this in our calculator and get some points. If we can get the calculator to turn on. So we're going to clear it out and put in negative, parentheses, x plus 2, parentheses, to the third power, -1. So from our normal one, it is down 1, inside lies, so it's left 2, and it's flipped, so it's going the opposite direction. So you can see it's on the left side. It's moved left from the vertex. And we're just going to get some points here. All right. And real quickly, let me change my settings here so it's not going by halves. We don't need that. So -4, 7. Looks to be about there. -3, 0. -2, -1. -1, -2. I believe it was 0, -9. So that gives us our general shape of it, like so. All right, next one is obviously a square root, because we have, well, a square root. It's moving left 2 and down 5, all right? So it should be left of the y-axis and below the x-axis. So let's graph this one and then look at the domain and range. So y equals, clear it out, second square root, x plus 2 underneath the radical, and then we move out of it and move -5 down 5. And there it is. So now we just go to our table. Obviously we have a bunch of errors because we cannot graph it left of -2. So it's -2, -5, and 2, -3, and 7, -2, and 14, -1. So we really can't graph that, just kind of guessing. And it looks something like so. So for domain and range, domain, whoops, how far left does it go? -2. And it's going towards +infinity to the right. It hits -2, so we use a bracket. How low does it go? -5. How high does it go? Infinity. And again, we use a bracket because it does hit at -2, -5. All right, this one is exponential. All right, it is moving left 3 because inside lies, and down 8. So again, we're going to let the calculator do the heavy lifting here. And we're going to put 2 to the power of, and we type in x plus 3. And we come out of that, and we write -8. And we're going to use the table to get some points. Obviously, way off. And here we go. So we can do 1/8. We can do 0, 0, and -1, -4. And we can do -2, -6, -3, -7. And there you can see it's going to bottom out before -8. So this is where our border is going to be. So just kind of come down there and write it out. So the domain is going left and right forever. The range, positive infinity, down to where? -8. But remember, it's never going to hit -8. Look at the calculator. Okay? Now, eventually the calculator will screw up and say that because it can't handle it, but it never hits -8. It just keeps getting closer and closer for infinity. All right. And our last one is going to be a quadratic with that little 2 there. All right. It's going to be thinner. It's going to be right 6 and up 1. And this, if you think about, remember vertex notation, 6, 1 is our vertex because it's in vertex form. So we go to our calculator, y equals, clear it out, and we put 2 parentheses x minus 6, close parentheses, square it, plus 1. And you can see 6, 1 is going to be our vertex. And we just go to our table here. And I'm just going to tell it to start at 0 or 1 to save the trouble. All right, so 151, obviously these are not going to work, so we need 4, 9, and 5, 3. So 4, 9, and 5, 3. And then we can do mirror images at 7, 3, and 8, 9. So left to right is going forever. So negative infinity to positive infinity again. Where's it bottoming out? At 1. And it's going up to positive infinity. It hits here, so we use a bracket. And there you have it. All right, now this is piecewise. So a few ways to do this. Okay, notice x is 3 is where our cutting line is going to be. There's a few different ways to do this. We can go to y equals and put in absolute value, so math over to 1, x plus 1, which means it's moving left 1, come out of it, minus 2, down 2, and hit graph. Now you can graph all this and then erase which side you need. we're less than, so we're going to erase the right side of this line. But we could also just start from 3. Now remember, at 3, 2, it's going to be an open dot because of this right here. So we go to 3 and put 2, and we're going to put an open dot right there. And now we're just going to graph everything to the left of it. We don't want these numbers bigger than 3. So we're going to go to 2, 1, 1, 0, 0, negative 1, and then negative 1, negative 2, and negative 2, negative 1. That's where it starts to bounce back, like so. Okay? And then negative x plus 8. So that is going to be, you could do this without a calculator. This could be the erase kind. So it's going to start at 8 and just go down like this, negative 1. Sorry about that. I meant to pay attention to that. And we just erase anything left of this line. And it's going to be a solid dot here. And again, you can use a calculator, but this is a really simple linear one. You don't really need the calculator for. And there you have it. Now, type is piecewise. Technically, on the overall thing, it's going left and right forever and up and down forever. Right? Now, where will negative 4 give us? So negative 4 is over here. We can either look at the graph and see that it's 1, or we can plug in negative 4 here and get negative 3. And the absolute value of negative 3 is 3 minus 2 is 1. Either way. Our next number is 10. That's over here. And we can see where 10 is going to hit. I'm a little bit off when I drew it, so it should be right there, actually. So that's why we use a straight edge. It's going to be a negative 2. Or, again, we could plug in 10 right here. Negative 10 plus 8 is negative 2. And 3, this is the tricky one, because we're not going to use this one because it's an open dot. So if we plug in 3 right here, 8 minus 3 is 5. Or again, if we look, where is it on the graph? 3, 5. All right. Find the inverse for this one. Okay, so first thing we do is we write y equals square root of x plus 6 plus 3. Then we switch x for y. And then we solve for the new y. So we're going to subtract 3. Then we need to get rid of this. So be careful. You got to put this in parentheses. So that's x minus 3 squared equals y plus 6. And then subtract 6. So y equals x minus 3 squared minus 6. And we could rewrite this as f negative 1 of x equals x minus 3 squared minus 6. All right, this one looks like it screwed up in the printing. So number 13, we're going to do the same thing here. So I'm just going to do this. Save a line. X equals 2 y plus 1 squared minus 8. Add 8 to both sides. Divide by 2. And then we square root both sides. which gives us the square root of x plus 8 over 2. The answer key says 1/2 x plus 4. Same thing. Equals y plus 1. And we just move the 1 over. So y, or in, f of negative 1, f inverse x equals negative 1 plus or minus. We always do that when we're doing square root. Square root of x plus 8 over 2, or again, 1/2 x plus 4. Oh, I guess it didn't mess up. It did print okay, sorry. Number 14. Graph this and its inverse. Okay, so we're going to graph this using our calculator. See if we can get the calculator to work. All right, so y equals, clear it out. Nope. And put in 2 parentheses x plus 3 squared plus 1. So we're going to graph that. Again, negative 3, 1 is going to be our vertex, because it's in vertex form. Now we just go to the table. And negative 2, 3, negative 1, 9. And then the mirror images, negative 4, 3, and negative 5, 9. Right? And then remember, you literally just switch the points, okay, for the inverse. So if this is negative 3, positive 1, so negative 3, positive 1, we're going to switch that and put 1, negative 3. All right? And if we had negative 2, 3, that's going to be 2, negative 3. Sorry, it was... Yeah, negative 2, 3. So we just switch them and do 3, negative 2. So 3, negative 2, right here. And we had negative 4, 3. So we just switch them, and 3, negative 4. And then negative 1, 9 becomes 9, negative 1. Negative 5, 9 becomes 9, negative 5. So you just switch your x and y values, and you have the inverse. That easy. Oops, I don't know why all that shifted down. Sorry about that. I don't know what happened. So dots don't line up, but you get the gist. All right. So it says find f of g of x given, wow, given these. Okay. So that means we're plugging g into f. So we're going to take this and plug it in to here. So 4x plus 3 squared minus 8. So remember, you can FOIL this off to the side or just do the shortcut. Square the first, 16x squared. Multiply and double. So 3 times 4 is 12. That's 24x. Square the last. And don't forget the minus 8. Now you just combine like terms. 16x squared plus 24x. 9 minus 8 is 1. F of g means the other direction. We're going to plug this into here. So 4 times x squared minus 8 Don't forget the plus 3. So that's 4x squared minus 4 times 8 is 32. Don't forget the plus 3. And that gives us 4x squared minus 29. And then careful here, we're plugging negative 5 into G and that new number into F. So G is 4 times x, which in this case is negative 5, plus 3. That gives us negative 20 plus 3, which is negative 17. Now this number is going to get plugged into F. So negative 17 squared minus 8. Please be careful. If you type this in the calculator and it says negative 289, use your brain and remember any negative number squared is positive. Well, any number squared is positive. And so therefore, 289 minus 8 is 281. And that's it.